Your porthole shows the same curve of blue and white it showed yesterday, and the day before that, and for hundreds of days before that. 16 times every 24 hours the sun rises and sets outside your window, and you stopped marking which sunrise. This is somewhere around the 5,000 orbit. A team of doctors on the ground is waiting to find out if your mind is still intact. For cosmonaut Valeri Polyakov, this wasn't a scheduling accident. This was the entire experiment. On January 8, 1994, you launch from Baikonur Cosmodrome aboard Soyuz TM-18. 2 days later, your capsule docks with the Mir space station, a cylindrical outpost orbiting roughly 250 miles above Earth, already built out with several added modules. After 8 years in service, you are a flight surgeon by training, a deputy director at Moscow's Institute of Biomedical Problems, and you have spent over 20 years waiting for this specific flight. Not a flight to set a record. A flight to answer one question with your own body. Can a human being survive physically and mentally long enough to reach Mars and come home again? You already know what waiting feels like. Born in the industrial city of Tula in 1942, you trained as a physician and specialized in space medicine before joining the Soviet Cosmonaut Corps in 1972. For 16 years after that, you watched other people fly while you monitored their health from a console on the ground. Your own first spaceflight didn't come until 1988, when you spent 240 days aboard Mir as its Dr. Cosmonaut. When you finally stepped back onto Earth, your first words were, "We can fly to Mars." That sentence wasn't a slogan. It was a hypothesis, and you spent the next 6 years building the mission that would test it properly. A round trip to Mars, even on the shortest workable trajectory, takes somewhere between 14 and 18 months. Once you add the outbound transit, a surface stay, and the trip home. No one in 1994 had medical data on a human body enduring anything close to that span in microgravity. The longest spaceflight on record at that point belonged to cosmonauts Vladimir Titov and Musa Manarov, who had stayed aboard Mir for 366 days, 6 years earlier. So the Institute of Biomedical Problems designed your mission to run deliberately longer than that record. Long enough to outlast even a Mars round trip's worst-case timeline, and you volunteered to be the one who lived through it. How do you prepare for over a year inside a metal tube with no replacement crew waiting to relieve you? You don't train for the launch itself. Launch lasts minutes. You train for the boredom, the muscle loss, the bone density, drain the radiation exposure, and the slow erosion of a mind that has nothing new to look at for over a year. Before liftoff, researchers measure your cognitive speed, your mood, your reaction times, and your sleep cycles. They will measure all of it again during the flight, and again after landing, and again 6 months later. This isn't a single test. It's a baseline you carry with you into orbit. So the people on the ground can chart exactly how Earth's absence changes you week by week, rather than guessing after the fact once you're already home. The first weeks are rough. Documented results from the mission, later published in a 1998 study titled Mental Performance in Extreme Environments, show a measurable dip in your mood and a rise in your sense of mental workload during your earliest days aboard Mir. Your body is adjusting to weightlessness, with fluids redistributing toward your head, swelling your face and draining your legs. Your inner ear stops trusting which way is down, and for a few days, simple tasks like reaching for a tool take longer than they should. None of that is unusual for a new arrival in orbit. What is unusual is how long you have left to go once those first symptoms fade. So picture the actual rhythm of a day at month 3. You wake inside a sleeping bag strapped to a wall, because in microgravity, floor and wall and ceiling stop meaning anything. You run 2 hours of mandatory exercise on a treadmill and a stationary bike tethered down with elastic cords, because without that resistance, your bones would start thinning at a measurable rate every single month, and your heart, no longer working against gravity, would begin to weaken along with them. Meals come from tins and sealed pouches, heated in a small galley unit, eaten while drifting a few inches above the table because chairs serve no purpose here. You run experiments, log readings, and repair equipment that breaks more often than ground control would like to admit. Mir was already an aging station by 1994, and a cosmonaut aboard it spent a meaningful share of each week simply keeping it functional rather than conducting science. You also talk constantly to Mir's other crew members who rotate out every few months while you stay behind. That detail matters more than it sounds. Other cosmonauts and astronauts arrive, complete their own shorter missions, and return home to families, gravity, and weather. You watch them pack their gear. You watch them strap into a descending Soyuz capsule. Then you watch the hatch seal shut again, and you keep going, because your mission isn't measured in months like theirs. It's measured in however long it takes to outlast a hypothetical trip to another planet. A timeline nobody aboard the station can shorten on your behalf, no matter how the schedule shifts around you. In February 1995, near the end of your stay, you watch through one of Mir's windows as the Space Shuttle Discovery performs a slow practice approach, nearby rehearsing rendezvous techniques for the docking missions that would follow under the developing Shuttle-Mir partnership. For a moment, two space programs built on opposite sides of the Cold War are visible from the same window, and you are the one person aboard who has been up here long enough to have launched before that partnership was even being planned. Mir also carries a small greenhouse module called SVET, where successive crews grow wheat and other plants under artificial light testing. Whether food could eventually be grown in orbit rather than shipped up entirely from Earth. You tend it during your months aboard alongside your other duties, watching seedlings push through soil in conditions no plant evolved for. It's a slow, unglamorous task next to running medical scans on yourself, but it points at the same long-term question your whole mission is built around. A crew traveling to Mars can't restock from a cargo ship the way Mir's crews periodically could. Whatever they need for 14 months, they either bring with them or grow along the way. Contact with home arrives in pieces. Ham radio links, occasional video calls, and messages relayed through ground control are the only threads connecting you to a planet you can see in full from orbit but can't set foot on. Your oral history interviewer later asked whether, given the chance, you would commit to an actual multi-year flight to Mars rather than another long stay in Earth orbit. You answered that you would, provided you got permission from your wife first. On record, her response was simply that you say things like that. Did your mind ever start working against you? The 1998 study answers that question with more nuance than a simple yes or no. Your mood dipped early, then climbed back to its pre-flight baseline somewhere between your 2nd and 14th month in orbit, and stayed there for the remainder of the flight. Researchers also tracked your performance on tasks measuring attention, manual tracking, and reaction speed, and found no lasting impairment to your cognitive function once you returned to Earth. The takeaway wasn't that isolation is harmless. Early weeks clearly took a measurable toll. The deeper finding was that the human mind, given structure, purpose, and enough time to adapt, can hold steady through a duration nobody had previously tested on a single person. NASA astronaut Norman Thagard, who flew aboard Mir in 1995 and briefly overlapped with your final weeks in orbit, later described you in an oral history interview as an outsized presence, even by cosmonaut standards. The kind of person who filled a room even when that room was a cramped space station module. During your final undocking sequence in March 1995, Thagard recalled you growing so excited at the thought of seeing Earth's surface again that crewmate Alexander Viktorenko had to tell you to settle down before procedure could even finish. That excitement makes sense once you do the math. By March 1995, you have been continuously in space for over 14 months. You have circled the planet more than 7,000 times. You have traveled roughly 187 million miles without ever once feeling solid ground beneath your feet. And you have done it while running the same medical experiments on yourself that you once ran on other cosmonauts from the safety of a ground station. Here is the detail almost nobody expects. The greatest threat to your survival on this mission was never a single dramatic failure. There was no explosion, no depressurization, no fire racing through a module, the kind of crisis that makes for an obvious headline. The real danger was slower and quieter than that. It was the gradual, almost invisible toll that time itself takes on a body and a mind with nothing to push against. Muscle atrophies without warning signs you'd notice day to day. Bone density slips away in increments too small to feel. Mood erodes in tiny steps long before it shows up as an actual problem on a chart. The force trying to defeat you for over 14 months wasn't catastrophe. It was simply duration, stacked one ordinary day on top of another for longer than any human being had ever been asked to endure it before. On March 22, 1995, Soyuz TM-20 carries you back toward Earth with crewmates Viktorenko and Yelena Kondakova. After landing, ground crews moved to lift you out of the capsule the way they typically do for cosmonauts returning from long stays, since muscles weakened by months of weightlessness often can't immediately bear weight under full gravity. You decline. You insist on walking the short distance to a nearby chair yourself, partly to prove a point to the doctors watching, and partly because, after 437 days and 18 hours in orbit, you wanted your own legs to carry you the last few feet home. That number, 437 days, still stands today as the longest single continuous spaceflight by any individual in history. More than 3 decades have passed since you said it, decades that saw the Soviet Union that trained you dissolve. Mir itself eventually deorbited, and an entirely new International Space Station rise to take its place in low Earth orbit. NASA's Scott Kelly came closest among American astronauts, completing 340 days aboard the International Space Station during the agency's Year in Space study. Christina Koch logged 328 days on a single mission. Frank Rubio set the current American single mission record at 371 days after an unplanned mission extension in 2022 and 2023. None has matched your 437, and no cosmonaut or astronaut from any agency has come within 3 months of it. Why has nobody broken a record set in 1995? Partly because no agency has needed to. Partly because the data your body generated already answered the medical question a longer mission would have asked again. Your flight proved that a trained, supported human being could endure a Mars-length mission's worth of time off Earth without permanent psychological or cognitive damage. And that proof has sat in agency archives ever since, waiting for a mission that would actually put it to use. Now consider where that proof might finally matter. Every space agency currently planning a crewed Mars mission, whether NASA's long-discussed Mars architecture or private efforts targeting the early 2030s, is working from the same baseline reality your body established first. Long-duration spaceflight doesn't have to break a human mind. It tests, it strains it in the early weeks, and then, if the structure and purpose are there, lets it settle into something stable enough to function for over a year without solid ground underfoot. Your flight also generated something less discussed than the mood and cognition data, a continuous 14-month record of how much cosmic radiation a human body absorbs outside the partial protection of Earth's lower orbits and magnetic field. Mission planners designing radiation shielding for future deep space habitats still draw on long-duration exposure data from missions like yours, because a 6-month rotation aboard the International Space Station simply can't substitute for over a year of continuous readings. Mars offers no equivalent magnetic shield to soften that exposure during transit, which makes every additional month of verified human radiation tolerance data. However unglamorous it sounds, as valuable to mission planners as the psychological findings that usually get the headline, that stability is the real legacy, more than the record itself. Every astronaut who now trains for a 6-month rotation aboard the International Space Station studies long-duration data that traces back to your 437 days. Every flight surgeon designing psychological support for a future Mars crew is working from a model your mission helped build. The Institute of Biomedical Problems still cites your flight as its core reference case for long-duration human endurance, decades after you returned and long after Mir itself was deliberately deorbited into the Pacific Ocean in 2001. One number written in the record books is a single 14-month flight. The quieter number written into every training manual and mission plan since is every year that followed. Built on what your body and your mind proved was possible inside a single Soyuz capsule and a station called Mir. Your porthole still shows blue and white, but you are not counting orbits anymore. You are home walking on your own two legs, and somewhere on the ground, the team that spent 14 months watching your mind hold steady finally has the data. It waited decades to use data that will outlive the man who generated it and may yet outlast every agency still arguing over when the first Mars crew finally launches.